Number 1, just differentiate that as standard. Number 2, either bring your x4 up as x to the minus 4. So power to the front and take 1 off. Number 3, write your root x as x to the half and then times out your bracket. You've got x squared, so square the first, double the product, so it's minus 4x, and square the last, times it all by x to the half. So x squared times x to the half, add them up, add the powers, 2 add a half is 2.5. Minus 1, that's x to the 1, times x to the half, add the powers, so it's 1.5, 3 over 2, and that's just 4x to the half. Then differentiate it. Number 4, square out your bracket. Square the first, double the product, so it's positive 2x, square the last, and write that as x to the half. Then split this up. So it's x2 times x to the half, subtract the powers. 2 take away a half is 1.5. That's x to the 1, take away x to the, or a half, gives you x to the half. And that is 1 over x to the half, so it comes up as x to the minus a half. Then you differentiate it as normal. Number 2, you're wanting to find the coordinates of where it crosses the x-axis and then find the equation of the tangent and normal. So, it crosses the x-axis when y is 0. So putting y to be 0 and solving that, you get x to be minus 1. So that's where it crosses. You want the tangent and the normal. Tangent equation, write it out. Normal equation, write it out. You've got to find the gradient. The gradient is when you differentiate y. So you can see up the top, I wrote y is x squared plus x to the minus 1. Remember, you cannot differentiate if x is in the bottom row, so you must write it out like this first. Differentiating that, you get 2x minus x to the minus 2. I wrote it a wee bit neater, as in 2x minus 1 over x squared. You were told that x is minus 1, so put it into your gradient to get minus 3. That's your gradient you put in here and down here. It's just a matter of timesing out those brackets and tidying that up. Next question, question 3. Find the stationary points. So basically you can't have x in the bottom row, bring it up as x to the minus 2, differentiate it. For turning points, put it equal to 0, solve it, get your x, substitute it in to get your y, that's your point. You've got to find the second derivative. So differentiate your dy by dx again to get your second derivative. Tidy it up, sub in your x value. You will see it's going to be a negative value. Negative means the maximum. Part 2. First of all, fix it. That is x to the half plus x to the minus half. Differentiate it. Turning point when you differentiate it and put it equal to 0. So you differentiate that, put it equal to 0. You can see me working through this now. It's a bit more of a complicated one. So I put this over to the other side. I crossed multiplied. So I had 2x to the root x3 times that. Try not to cancel anything off. Bring it over and then factorise out your root x. If you factorise out a root x, you're left with root x squared minus a 1. On this bit, put each bit equals 0, so root x equals 0, so x is 0. That actually becomes x. That actually cancels off to give x equals x minus 1, so x equals 1. You've got your x points, just as usual, work out your y. That's giving you a 0 in the bottom line, which you can't have, so it's impossible. So work with this one. When x is 1, sub it in to get your y. Again, don't forget your second derivative. You've got your dy by dx up there. Differentiate it again. Sub in your x. It's bigger than 0, so it's minimum. Number 4. This is quite a complicated one. So you've got y equals this. And when x is 1, let's work out the y coordinate. That's the first thing I did. I worked out the gradient. So I differentiated it and I put in the x. So I've got the gradient. Now it's talking about the normal and the tangent. So here's the normal and here's the tangent. So just putting in your x and your y values. So normal and tangent. It's then talking about Q is the point where the normal at P meets the curve again. So the normal, here it is, meets the curve when they're equal. There's your normal and that's your curve. Put them equal and solve that out. It's me just going through the different processes of solving it out. You get x equals 1 and x equals 4. X equals 1 was the point they gave you. This is P. So you're talking about finding what happens when X is 4. You can sub X equals 4 into either the normal equation or the curve, because they both meet, they're both at that point, to get your Y coordinate. That's your Q. Then you're told R is the point where the tangents P and Q meet. So I've got to do the tangent at P and the tangent at Q. Now at the minute I don't have the tangent at Q, so I'll go over here to work out the tangent at Q. There's a tangent formula. Put Q in, put your Q coordinates in. Work out your M. M is when you differentiate. So at Q, X is minus 4, so that's your M value. Put it in. So that's your tangent at Q. So now you've got tangent at P and tangent at Q. They meet each other. So put them equal to each other and solve. Get your X coordinate out. Then sub it into either of these tangents, because that's the equations we're talking about, to get the Y coordinate. Then you've got the point R. Now, what we have to do here, I'm just having a look here. So I try to draw out the gradient of, you're looking for the area of the triangle PQR. So drawing it out helps. You've got a normal and tangent, so there's right angles in there. So the area is the base, this length, times the height divided by 2. So I've got to work out this length, PR and PQ. So here's PQ being written out. The length of the line is a difference in X is squared plus a difference in Y is squared, all square rooted. So working with your coordinates P and Q, find the difference in the X's, square them, find the difference in the Y's and square them. Now I've got to do the same for PR to get the length of this. So it's the difference in the X's squared plus the difference in the Y's squared and square rooted. You've now got the length of that line and the length of this line. So area is the two lengths times together divided by 2. Very tricky question, just take your time working through that.